Have you ever gazed upon the night sky and wondered if somewhere out there, someone or something was looking back? A question that has sparked the curiosity of humankind for centuries. Imagine the universe, a cosmic sea, infinite and majestic, teeming with billions of galaxies, each filled with billions of stars. Wrapped around these stars potentially are planets, many of which could be just like our own Earth. Now think about this. If there are billions of potentially habitable planets out there, then isn't it possible or even probable that life, as we know it or as we can't even begin to comprehend, exists somewhere out there? This possibility opens up a Pandora's box of questions, the most intriguing of which is presented in the form of the Fermi Paradox. And that brings us to the cosmic question we are going to explore today. If the universe is so vast and teeming with potential life, then where is everyone? Enter the Fermi Paradox, a question that has puzzled scientists for decades. This intriguing concept takes its name from the physicist Enrico Fermi, who, during a casual lunchtime conversation with colleagues in the summer of 1950, posed a seemingly simple question: where is everybody? In essence, the Fermi Paradox is a contradiction, a cosmic conundrum that grapples with the high probability of the existence of extraterrestrial civilizations and the stark lack of evidence or contact with such civilizations. Imagine the universe as an infinite expanse, bustling with billions upon billions of galaxies. Each galaxy is a swirling mass of stars, many of which are likely to have planets orbiting them. Given the sheer number of stars and planets, the laws of probability suggest that there should be a multitude of planets that harbor conditions suitable for life, much like our Earth. In fact, scientists estimate that in our own Milky Way galaxy alone, there could be millions of planets that are in the Goldilocks zone, a term used to describe a region around a star where conditions are just right, not too hot, not too cold, for life as we know it to potentially exist. Despite these compelling statistics, we've yet to receive an interstellar phone call or discover an alien artifact. Our radio telescopes, pointed towards the stars, remain eerily silent. We see no signs of intergalactic engineering or cosmic construction projects. No extraterrestrial visitors have arrived on our doorstep, and we've found no definitive evidence of biological activity on other planets or moons in our solar system. This stark contrast between the high probability of alien life and our lack of contact with such life forms the crux of the Fermi Paradox. It's a paradox that challenges our understanding of the universe, our place in it, and the nature of life itself. This paradox, named after physicist Enrico Fermi, leaves us with the big question: where is everybody? Opening. There are numerous theories that try to answer this perplexing question. The Fermi Paradox, the seeming contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations, has sparked a multitude of explanations. Some of the most popular ones include the rare Earth hypothesis, the idea of self-destruction of advanced civilizations, and the possibility that we are simply not listening correctly. Firstly, let's delve into the rare Earth hypothesis. This theory suggests that the conditions necessary for intelligent life are incredibly rare in the universe. It's not just about finding a planet in the habitable zone of a star. A multitude of factors need to align perfectly for life to take hold and evolve into an advanced civilization. Factors like a stable star, a planet with a magnetic field to protect against harmful solar radiation, the right chemical elements, and a lot more. So, according to this hypothesis, we might be alone in the universe, not because life is impossible elsewhere, but because it's incredibly rare. Next, we move on to a more ominous possibility, the self-destruction of advanced civilizations. This theory posits that any civilization advanced enough to reach out into the stars is also advanced enough to destroy itself. It's a sobering thought, isn't it? Whether it's through nuclear war, ecological disaster, or some other self-inflicted catastrophe, civilizations might wipe themselves out before they get a chance to make interstellar contact. It's a grim theory, but it's one that can't be entirely ruled out considering our own civilization's close calls. Finally, there's the idea that we are simply not listening correctly. This theory suggests that we might be looking for the wrong signs or using the wrong tools. Imagine trying to catch a TV signal with a radio. It's not going to work, right? Similarly, extraterrestrial civilizations might be using forms of communication that we haven't discovered or developed yet, or perhaps they are intentionally staying quiet to avoid detection. It's like we're playing a cosmic game of hide and seek, and we're still figuring out the rules. These theories, among others, attempt to resolve the Fermi Paradox. They range from the scientifically grounded to the highly speculative, from the optimistic to the downright terrifying. But the truth is, we don't know. Despite all our advancements, despite all our knowledge, we are yet to find a definitive answer to the cosmic question posed by the Fermi Paradox. Closing, yet none of these theories provide a definitive answer. Despite the lack of a clear answer, the Fermi Paradox holds a significant place in our search for extraterrestrial life. This paradox, this cosmic puzzle, spurs us on a quest for knowledge and understanding, driving the wheels of scientific research and exploration. The Fermi Paradox is not just a scientific conundrum, it's a philosophical one. It pushes us to ponder about our existence, our significance, and our place in the cosmos. It prompts us to question, are we alone? Are we unique, or just an ordinary occurrence in the vast expanse of the universe? These questions might be daunting, even uncomfortable, but they are fundamental to our understanding of life, existence, and the universe. The Fermi Paradox also has practical implications. It fuels our curiosity and encourages us to venture into the unknown, to reach for the stars, quite literally. It has been a driving force behind space exploration initiatives, from the launch of the Voyager spacecraft to the search for exoplanets. Every effort to listen for extraterrestrial signals, every mission to explore distant celestial bodies is in part a response to the Fermi Paradox. Moreover, the Fermi Paradox has inspired a multitude of theories and hypotheses, expanding our perspectives and challenging our preconceived notions. It has sparked debates and discussions, pushing us to think critically and creatively, to imagine and speculate. It has stimulated scientific and philosophical discourse, fostering a culture of inquiry and intellectual rigor. And perhaps, most importantly, the Fermi Paradox serves as a humbling reminder of our limited knowledge and understanding. It underscores the vastness of the universe, the complexity of life, and the enormity of our quest for comprehension. It reminds us that there is so much more to learn, so much more to discover. The Fermi Paradox challenges us to explore, to learn, and to strive for a better understanding of our universe. It is indeed a paradox, a mystery, but it is also an invitation, a call to adventure, a beacon guiding us on our cosmic journey. The Fermi Paradox doesn't discourage us. Instead, it fuels our curiosity. This paradox, this cosmic conundrum, has become a symbol of our relentless pursuit of knowledge and truth. It stands as a testament to our innate desire to reach out, to explore, and to understand the universe that surrounds us. The Fermi Paradox isn't just about the existence of extraterrestrial civilizations or the deafening silence from the cosmos. It's much more than that. It's a reminder that there are still mysteries to be solved, questions to be answered, and worlds to be discovered. It's a call to arms for the thinkers, the dreamers, the explorers among us. It's an invitation to challenge what we know and to push the boundaries of our understanding. And so, we continue our journey. Every day, we learn more about our universe. We send probes to distant planets, decode the light from far-off stars, and delve into the very fabric of space-time. Each discovery, each revelation brings us one step closer to answering the question posed by the Fermi Paradox. Yet, as we strive to unravel the universe's mysteries, we must remember that it's not just about finding answers. It's about the journey, the quest for knowledge, the thrill of discovery. It's about looking up at the night sky and feeling a sense of wonder, a sense of connection with the cosmos.